We're now going to do an example that I really like here. One reason I like this example is it's going to show you how a regression line might actually be a useful thing to know how to do. So this is the kind of the original example where there's a researcher that records how many hours someone works outside of class and their grade point average, and they notice that there's a pretty strong negative correlation. Okay, and here is the R value, so it's fairly strong. When we tested it at alpha equals 0.05, we saw that there was enough evidence to conclude a correlation. So now what I would like you to do is to determine the regression line. So use those 4 steps and find out the regression line. Have it written out, y equals a plus bx. Okay? And then when you're done, I'll have you resume the video, and then we'll discuss a little bit about why this regression line. Well, first I'll calculate the regression line. You can check your work. And then we're going to discuss why this regression line might be helpful to somebody. So, go ahead, pause the video, determine the regression line, and then resume it. And then you can check your work, and then we'll have a little discussion about this. So. Okay, so I'm going to go ahead and calculate this regression line, and you can check your work and see how you did. So step 1, we need to find the slope, b, and so this is SSXY, which is this one, and over SSX. So I'm going to use those. So we got negative 35.18 divided by 820. And I'm going to go ahead and round these to 3 decimal places. So 35.18, negative 35, divided by 820. And I get a negative 0.043. So this will be the slope when I round to 3 decimal places. Okay? So now, step 2, before I can calculate A, I need to get X bar and Y bar. So X bar is just going to be the sum of X, which is 105 over 5, and that's equal to 21. So that's the average number of hours that they work. And then Y bar is going to be the 14.67 divided by 5. So 14.67 divided by 5. And this is like 2.934. I'll just go ahead and keep all those decimal places since it terminates, and grade point averages are to 2 decimal places. So we'll just use all 3. So now those are my averages. So now I can calculate A. A is going to be the Y bar. So 2.934. Okay. This will be plus, and this is a negative 0.043 times X, which is 21. And you can put this in your calculator just like that, or when you multiply these two together, it'll be negative. And so you could rewrite this, or you could have wrote it like this to begin with if you know the slope is negative 0.043 times 21. So either way, I mean, you get the same thing. So 2.934 minus 0.043 times 21, and I get let's see, that's not Oh, you know what? I did this wrong. I wrote this in wrong. Sorry, I'm sorry about this, but this should have been a minus. So it's y bar minus b times x bar. And so the two here, the two subtractions will make that a plus. Okay? And so I think I put the plus there because I was thinking ahead that they would cancel each other out. So this should have been a plus, and there you go. This is what I was thinking it should have been. Okay. So you got to be careful if you got some negatives here in your slope or whatever. You need to pay attention to that. So this is my A, this is my B, so you could write y equals the A plus, and then the B would be negative 0.043 times x. So you could write it like this, and this is kind of what I think I was thinking here, is you could also write this as 0.043x. So the negative slope could be written like this. Okay, so but either way is fine. You have your regression line. And so what I want to do here then, once we have this regression line, I want to talk about why this might be useful to somebody. So suppose you are an academic advisor and you advise students as they plan out their schedule. And a student comes to you and tells you, they tell you that they have a scholarship that's important for them to keep, but in order to keep it, they got to maintain a 3.5 grade point average. And they tell you that, they tell you that they're working like 25 hours a week, and they want to know, what do you think I should do? Should I cut back on my job? It's important that I maintain a 3.5. What should I do? Now, you could just tell them, what you think is a good idea off the top of your head, like, well, that's probably okay if you work 25 hours, but you'll want to make sure you really work hard, or something like that. But if there's any data that you could gather that would help you make the decision, or help you in the decision-making process with that student, then it would be helpful to know what that is. And this would be data that might be helpful. So what you could tell the student is that there has been a study that has been done that shows that there is a strong negative correlation between the number of hours someone works and their grade point average, and they've even determined a regression line here, though you might not call it that. You might say it's a formula for predicting what the grade point average would be given the number of hours someone works. And so they work 25 hours. And so what you can do is you can plug this in, and this would give you a prediction of what their grade point average might be. Okay. So 3.837 minus 0.043 times 25. And it looks like their grade point average is predicted to be 2.762. So in this case, they wouldn't be able to keep their grade point average, okay? Now, it doesn't mean that is, they wouldn't be able to keep their scholarship. Now, this doesn't mean that is what their grade point average would be, because these are scattered a little bit, okay? And so, I'll try to draw a line of best fit. And so at 25 hours, you get this, and that's how you're predicting at 25 hours that it's going to be 2.762. Now, these points are scattered, and they might be, a little more extreme, scattered a little more than other ones, especially if they're trying hard. So it doesn't mean that they're going to get that. But if it's just like any other semester, and this is the general trend of the data, and the correlation is really strong, then there's a good chance they might not be able to maintain the GPA that they need. Okay, so now what you're doing is you're using data to help inform them of the situation and give them advice. So let's say you shared this with a student and he said, oh, well, how many hours would you recommend that I work? And so another thing that you could do, and this, you're not asked to do this in any of the homework, but one thing you could do is you could set this side equal to 3.5. The y needs to be 3.5. They got to maintain a 3.5. And then what you can do is you can solve this equation for x. And then that would be the number of hours that would predict a 3.5 grade point average. So by using a little algebra here, so I'm going to subtract 3.837 from both sides, and I get a negative 0.337. And then I'm going to divide both sides by 0.043. And then I'm going to get x is equal to, so negative 0.337 divided by negative 0.043. And it looks like 7.837 hours. So you could tell them around 7 hours, maybe 8 hours would be a good number of hours to work if they want to make sure to keep that 3.5 grade point average. Okay, so you can see that this sort of data can be useful in the decision-making process. And if you think way back to the very beginning of the class, we defined statistics as ways of collecting, organizing, analyzing, and ultimately drawing conclusions from data, using the data to inform the decision-making process. And that's exactly what you're doing here. So this is a great place to end the course, because we are giving you an example of how statistics can be used to help inform the decision-making process. So one other thing I wanted to show is to show you that this actually does make sense, because this is the y-intercept, and that's, if this is the line of best fit, then it does seem like this would be a little bit below the 4, right? And then the slope is negative, and it's a very small negative number, okay? Because these are going up. For every 1 hour you go over, this line goes down very, very little. The grade point average will go down. So it's kind of like starting here, and the grade point average goes down little by little, okay? So the other thing is that this is not a true example. At some point I made this data up, so excuse me, so there's not necessarily a correlation between these two things. I've often thought it would be very interesting to collect data from the students and to see whether or not there actually is some sort of correlation between these two variables. I've never done that though. So, but that's a really nice example. I like this example. I hope you like it too. What we're going to do then in the next video is I'll have one more example for you to do, and this is going to take you from beginning to end, everything that you've learned in Chapter 10. So scatter plot, calculate R, you know, the test, the regression line, all of it. So if you can complete the next problem, then you're in good shape. You know exactly what we're doing in Chapter 10. So go ahead and click on that next video and then take some time to see if you can do it, and then you can start the video up and see how you did.